In today's session, we shall discuss about the Fourier series under the chapter Analysis of Complex Waves. What are Fourier series? A Fourier series is the representation of a periodic function which is a function of time in terms of an infinite sum of sine functions and cosine functions. So these Fourier series were first introduced or invented by French mathematician, he is also a physicist, Jean Baptiste Joseph Fourier, presented the Fourier series in his Analytical Theory of Heat in 1822, which is the theory about heat diffusion in solid bodies. He used his Fourier series in the analysis of heat flow and the distribution of heat in the solid bodies. He proposed that any function could be written as an infinite sum of trigonometric functions of cosine and sine functions. He showed that the conduction of heat in solid bodies may be analyzed in terms of infinite mathematical series we call by his name as Fourier series. These Fourier series are very much useful in the analysis of any complex periodic motions. By the Fourier analysis, it is useful in our day-to-day life for many processes. For example, it is useful in signal processing, image processing, heat distribution mapping, wave simplifications, radiation measurements, etc. Many sound waves or the musical waves, which are a combination of different waves of different frequencies, and they become complex in nature. So for example, we hear a music which is a composition of different music from different instruments. Each and every music which are generating from different musical instruments will be combined together and it will be a complex in nature. So therefore, to analyze these musical tones which comprises of different frequencies, and if you want to decompose or remove any frequency, and if you want to separate the frequencies belonging to different musical notes like that, we use the Fourier analysis. By using the Fourier analysis, we can decompose the complex wave or a complex function into small similar functions. For example, the sound which is produced from our vocal cord is also complex in nature. It is also comprised of different frequency waves, and analysis of all these complex functions can be done using the Fourier analysis. Therefore, Fourier analysis is the study of how general functions can be decomposed into trigonometric or exponential functions with definite frequencies. The vibration being in the same direction, that is along the same straight line, gives rise to synthesis and analysis of complex vibration. This leads to the development of Fourier theorem. Now let us see what is Fourier theorem and what it states. Fourier theorem states that any complex periodic motion can be represented by component motions which are simple harmonic having frequencies in exact multiples of the frequency of complex periodic vibrations. So this can be understood by taking an example, and if we analyze that. So now let us consider a finite periodic motion, and it can be expressed as a sum of series of simple harmonic motions of corresponding frequencies. Let us consider a function, a sine function y1 is equal to a sin omega t, where it represents the instantaneous variations, a sinusoidal variations, where a represents the amplitude, omega is the angular frequency. Now consider another periodic function which is representing a cosine function y2 is equal to b cos omega t, where b is the amplitude and omega is the angular frequency. Now if you add these two, if you sum of these two periodic functions, we get the resultant, that is y is equal to y1 plus y2, which results as a sin omega t plus b cos omega t, which is complex in nature. So in this figure you can understand how two simple harmonic motions or two simpler functions are added together to give a complex motion. So in this complex motion, complex wave, it represents the variations of the amplitudes, and it is not easily understood how it is moving and how it is originated. Therefore, by using the Fourier analysis, we can split or decompose such a complex wave into its components. So like this, like these two waves. If we go in reverse, we can understand how the complex wave is decomposed. So here is another similar complex wave representation. So in the figure, the dotted line represents the wave, a complex wave, which is a combination of component waves. So the sum of a number of sine waves like this will give us the generation of a square wave or a sawtooth wave like that, which is very much complex in nature. Basically, these are the combinations of simple harmonic motions. We will discuss about a square wave and the sawtooth wave in our coming sessions. So now let us understand the Fourier theorem, and this is the representation of a Fourier theorem in a mathematical form. The Fourier series can be represented as y is equal to f of t, that is equal to a0 plus a1 sin omega t plus a2 sin 2 omega t plus a3 sin 3 omega t plus etc. up to infinity, plus adding the cosine functions, the series continues, plus b1 cos omega t plus b2 cos 2 omega t plus b3 cos 3 omega t plus etc. So this is a Fourier series. Here you can look into the summation of the sine functions as well as the cosine functions, and it will give us a Fourier series. In general, so the Fourier series can be represented in a compact manner by summing up. By using the summation symbol, we can represent the Fourier series as y is equal to f of t, that is equal to a0 plus summation from n is equal to 1 to infinity of an sin n omega t plus summation from n is equal to 1 to infinity of bn into cos n omega t. So here the terms a naught, an and bn, so these are all the constants which are called the Fourier coefficients. In the next slides we can have a discussion about the evaluation of the Fourier coefficients such as a naught, an and b.